So web performance is a billion-dollar industry, and there are hundreds of different techniques for improving the web performance of a site. But I'm going to share with you today one technique, just one technique that I believe makes the biggest difference. So I'm David Jeyachandran, and let me share with you. I'm a software engineer from Australia, and I've spent the last 10 years working for a Christian mission organization in Peru and making sure sites work well on low bandwidth and on older devices. So here's a photo of my wife with our 3 kids. We're now back in Australia, and I've recently got a job with another company called Sonda that I'll be starting soon. So how did I get connected with the New York Web Performance Meetup? So working in Peru, there are very few web performance meetups in the world, and Sergey, as an organizer, is very knowledgeable in the world, and it's been great to meet up with other people who are passionate about web performance. And it also happened to be in the same time zone as Peru. So I've been to New York once before, and this was before kids, and this is a magical moment on... I think some of you will recognize this spot. We watched the sunset on the top of the entire Empire State Building. So roughly what we're going to do, I'm really looking forward to the end where we're going to inject some JavaScript into some websites and see what prefetching can do for them. But first, let's start off with just a really basic question. Why a sub-second page load? Why should we even try for a sub-second page load? So Amazon, they estimated that if their website, Amazon.com, was 1 second slower, it would cost them 1.6 billion in lost revenue every year. The BBC, so it's not just for e-commerce sites, the BBC calculated for every second slower that their website was after 3 seconds, they lost 10% of their users. And for me, I was working in Peru, and so we know that for big companies, they potentially can lose thousands, or in Amazon's case, $1 billion. But working for a smaller organization, my motivation was getting our sites accessible to as large a group of people as possible, even if they had low bandwidth and older hardware. Okay, so why sub-second? So performance is important, but why set this 1 second goal? So we can understand how a slow website creates friction, and the more friction there is, the slower the site, more people leave. But yeah, why the 1 second? And to answer that, we need to look at psychology. There's actually been a huge amount of research on this, so multiple large studies in the area of human attention. And there are 3 limits that several studies have shown: 100 milliseconds, 1 second, and 10 seconds. So 100 milliseconds is what we perceive as instant. So if you blink, that takes between 100 and 300 milliseconds. And that's what we perceive. 100 milliseconds is instant. 1 second, when you take an action for 1 second, you are completely focused on that action. Then after 10 seconds, your mind begins to wander. And if we apply that to websites, when you click on an action on a website, we need to respond within 100 milliseconds. And you'll see this go wrong, where people click on a button multiple times because something hasn't worked. So websites always need to give an instant response to an action. But of course, you can't get a response from a server within 100 milliseconds. If a website is able to respond in 1 second, no one leaves. But after a second, slowly, people's interest starts. People get distracted. I'm sure you've all experienced where you've clicked on a link, you've waited, and then got distracted and have done something else. So between 1 and 10 seconds, people start leaving. And after 3 seconds, the number of people who start leaving drop off. And if the website doesn't respond in 10 seconds, basically everyone leaves. So if you can respond in 1 second, you don't lose anyone. So why is this a hard problem? Sub-second websites would be great, but you might think bandwidth is constantly increasing and phone hardware is getting better. Maybe we don't need to try very hard. A lot of us have very fast internet connections in our home. So is this really a problem we need to work at? So let me give you an analogy why just getting more bandwidth won't solve the problem. So if you imagine 2 cities, you want to get supplies from one city to another as soon as possible. Currently there's just 1 lane. If we double the number of lanes, there would be less congestion. So you would say this truck could get to the other city much faster. If we double that again, the increase in speed would be less because congestion is less of a problem. But if you thought, I really want to get this truck across the other city as fast as possible, maybe I could add 100 lanes. But you would say to me, no, that's not the problem. Once you've eliminated the problem of congestion, you just need to get that truck moving faster. And if I relate that back to websites, as we increase lanes, that's like increasing capacity. And there's a limit to how much that will help us. Ultimately, we're limited by the speed of that truck, which is the speed of light. So it's the time it takes for that truck to get the data to our browser. So the thing that is really limiting us is not our bandwidth, because bandwidth is about capacity. What's limiting us is the speed of light and what we call latency. So latency is the round trip to the server and back for our data. And obviously light travels really fast, ridiculously fast. So why would that be a limit? So here's an example of what we call the TLS handshake. When we establish a connection, there's at least 3 round trips before any data is communicated. So any kind of, when you're browsing a website, there are a lot of round trips. And latency means waiting. So we wait for that first HTML data to come down, and then that HTML gets images, JavaScript, and CSS to come down. And then that CSS, that JavaScript gets more fonts, more JavaScript, and more CSS files to come down. And between each of these steps is more waiting, which is latency. We can't reduce latency very easily because we can't get faster than the speed of light. We can't change the laws of physics. And that reminds me of Star Trek, where Scotty was always frustrated.
Scotty, I can't change the laws of physics.
He was always frustrated with the laws of physics. So while we can't change the laws of physics, we can do things to get around it. So one common technique is to use CDNs to bring the data closer to us. But also, there's only so close we can get a server to our browser. Ideally, we've got the server right next to our browser, which brings us to intelligent prefetching. So we can't change the laws of physics and we can't change the speed of light. And I think I've shown that just increasing bandwidth won't solve our problem. We could also reduce the size of a website. I've experimented having a website of just 6K. But even that, the problem is not the bandwidth, it's latency. So we can't beat the speed of light, but we can find a way around it. So let me give you an example how prefetching works. So here's a website where it's got several links. As hundreds of people use a website, they click on links And as people click on links, analytics data is being recorded. So in this example, for example, you've got someone has come from the home page and then clicks on this link called the Pomodoro technique. And as hundreds of people use the website, we can build information of how the website is being used. And so when you come to the website is able to respond with information on, from this particular page, what are the most likely links you will click on. So, for example, the first link, 30% of you're 30% likely to click on this link, and the next article 28%. And so, what the site can do is pull down the HTML for those links. So when you click on that link, it opens instantly. So you've basically got zero latency because the data for those links is not on a server far away. That's been brought right into either your browser cache or into memory. And you might be thinking, here is a diagram which shows the data brought right to your browser. You might be thinking you're downloading a lot of information, but if we prefetch, for example, just the HTML or just some key resources, the HTML, for example, is normally very small, something like 10 to 50K compared to an entire web page, which might be 3 or 4 megabytes. And Sergey mentioned it's the user experience, and often prefetching the HTML is what gives us the perception of a very fast page load. And we can load the images, etc. afterwards. So how does it work? We've looked at how a website can give us the data of which links are most likely to be clicked on. How does the website then pull that data down? And there are a few different techniques. You've got link types, service workers, and custom JavaScript. The link type is where you can create links where you've got 3 different types of tags: a DNS prefetch, prefetch, and a pre-render. A DNS prefetch is the least expensive, but makes the least impact if you click on the link. And a pre-render is if you're absolutely certain someone is going to click on this link, this will not only download the content, but also pre-render it, so it gives you the best user experience. As far as I know, Safari still haven't implemented this. So we've got great browser support, but unfortunately, so Internet Explorer and Safari, please correct me if I'm wrong, still haven't implemented this. Another way, and Sergey actually suggested this to me, and I think this is the future, using a service worker. So in this particular code, we've got, we're adding to the cache a bunch of different URLs. And then later, in the service worker code, whenever someone opens a web page, the service worker acts as a reverse proxy. So it checks whether each resource matches what's in the cache. And if it is in the cache, then it returns the cache response or it goes to the network. And it has the added benefit also of allowing websites to work offline. And yes, of course, there's also the option of just writing custom JavaScript. So we can use a fetch to get the HTML, parse it, and then apply that HTML. So libraries and limits. We can't change the laws of physics, but we can work around it. Rather than writing all this code ourselves, there are some libraries that we can use to take advantage of this. So the main library so far is one written by Google, and it's open source. It's called guest.js, and it uses Google Analytics data to be able to predict which links that you are likely to click on. It uses also the link prefix to actually fetch the data. If you're using React, so if you're using, say, Gatsby or Next, this is already baked into that technology. And if you're using React, it makes a lot of sense to use the Guest.js library. I've also developed a library called Faster Web, and my aim has been to make it ridiculously easy to implement prefetching. So with Guest.js, you need to set up a node server and a database. And with Faster Web, it's a library where I've set up a backend service that you can use. And so Guest.js, you set up a server, there's a script, you need to add some JavaScript code to each page of your site and a database setup. And with Faster Web, there is a backend service. So you just need to set up a script that calls that service. So let me give you a demo of Faster Web. So this is a demo site where I'm showing some of the data of what's happening under the hood. So let me reload this site. So after loading the site, the Faster Web service responds with the most likely links a person is to click on. So we can see, for example, here, the Pomodoro technique, there's a 14% likely chance that you're going to click on this link, and a 24% chance that you're likely to click on this link. And the HTML for those links has been downloaded and is ready. So if I click on that link, it opens instantly. If we look at the page load time, the time to load that HTML is 0 milliseconds because that HTML was already in memory. And it took 16 milliseconds to apply that HTML to the page. And what I'm doing here is I've got the source page, which was the home page. I've then got the target page. So if you click on the link, what I do is I do a diff between the current page and the target page, and I apply that diff. So something like a React, the way React works to change just the change elements. And so that is incredibly quick, 16 milliseconds. That's just to apply the HTML. So with any page, there's the HTML, there's also images. So images still have to load, but the HTML is applied almost instantly. So I'll click back to the home page. I could click a link that has not been prefetched, and that's fine. If I click on that, it takes a bit longer to load, but the aim is to give the best user experience to as many people as possible. So I hope you've seen, with the prefetching, you've got amazing performance. Like a page is able to open in less than 100 milliseconds, which is instantaneous. But the way that I've implemented has some issues. So to get that really rapid change, I have removed the page load and using this React-like diff to change the page. And so there are consequences for that. It means that the onload event and the DOM content loaded events, all the events that run when a page normally loads, don't run. So if you've got JavaScript running on a page, that doesn't get triggered. The way I've got around it with the sites that I'm looking after is I've got a configuration when I call the Faster Web service, where I put in, first of all, links that I don't want to prefetch. This was very interesting, where when I first implemented this, one of my colleagues kept complaining, every time I go to this page, I have to keep logging in. And the reason for that is when he hit this particular page, it would prefetch the logout link. And so he kept logging in, but it would then keep logging him out. There are also pages that we don't want to prefetch. So when you're working in the administration section, we may not want to run this. So you can choose the prefetching just to run on certain pages and not on other pages. This is the bit I wanted to show you, because we've changed the way pages are loaded and we're not running the onload event. With the Faster Web Library, you would need to define, what I do is define upfront what code to run when a page loads. So I'm sending the Google Analytics code. The back end of this website is built in Drupal. So Drupal actually, if you build a website the Drupal way, you actually flag all the onload events in something called behaviors. So I can just call a function, and Drupal will look after the calling the code that needs to run on an onload event. On other sites, I've had to say on, for example, the contact page, run this, or on the home page, run the slider code for JavaScript, etc., because all of that doesn't run automatically. If I've also implemented this using a service worker. A service worker does not give us the millisecond load, but it avoids many of these problems. And I think thanks to Sergey for showing me the service worker. So I've demonstrated one implementation of prefetching, and I hope I've demonstrated that of the hundreds of different optimizations you can do, prefetching can potentially make the biggest impact. But there are limitations, and especially with my example, the limitation was with the onload event. There are other limitations. What about using additional bandwidth and memory? The way a lot of services work is just prefetching the HTML. You can also prefetch resources. If you just prefetch the HTML, the resources are quite small, but you can, of course, prefetch other resources. And it's always a tension of, if you do too much prefetching, you actually work against the user experience by downloading too much. If you do too little, then you don't take advantage of prefetching. Both the libraries, Guest.js and FasterWeb, will not run the prefetching if someone on their mobile phone is on data saver mode, and you can set up rules. So, for example, if someone is on a certain type of network, you either do more caching or less caching. So, if someone has an amazing connection, maybe you prefetch all the possible images rather than on a limited bandwidth, you might need to prefetch less. But another potential question I've been asked is, what about unpredictable people? You're always going to have people who don't do what most people do, and that's fine. You want to create an amazing user experience for as many people as you can. Other people have asked me, what about dynamic sites? Does this only work for static sites? So I'm using this on sites where the content, some sites where the content rarely changes, and on other sites that the content changes frequently. What you can do with sites that change frequently is, when you're looking at the window of data that you've collected, you could say, just use the last 100 visits to calculate what to predict, or use, say, 1,000 or 10,000 visits. And both Guest.js and FasterWeb, both you can set which limit you want to use, either using a very recent data set or a wide data set.
I see Greg is asking a question. How would you compare prefetch versus server push?
Okay, so they're very different technologies, where server push avoids latency by once you download the initial page, the other resources, you don't need to wait for the other resources to be requested, so you avoid a round trip. But from what I've read, server push hasn't been very successful, so has not been recommended. So someone else, maybe Sergey can speak a bit more about server push. But my understanding is there have been some issues with server push, and so in HTTP, the newer versions of HTTP, I think server push doesn't work in the same way as with HTTP 2.
Yeah, I cannot speak to like exact details of server push, but for me, from what I understand, effectively server push can only push additional resources. It cannot really give you next page, right? It cannot really reload the page for you, right? As from the server. I mean, you could potentially use the server push or some other technologies to package next page's resources with that page, right? Like help that next page that you intelligently prefetch to get more resources. But generally speaking, first request is required, I would imagine.
Great, thank you, Sergey.
Yeah. So
another.
Ron, Rich is saying that he heard that Chrome team is deprecating server push. We have another question from Christian, actually. How many data points do you need to do good prediction? With just a few hundred or even 1,000 visits, you only get a few data points per link to on large content sites like e-commerce or media.
Yeah, I think that really depends on your site. The more data, of course, the more useful it is. On our sites, we've always got thousands of data points per page to each link. So, and it's a balance between what data window you can use. So you could use just say the most recent today's data, for example, because your page is changing every day, or you could use a month worth of data if your site doesn't change very often. So yes, I think the more data points you have, the more accurate your prediction is. But that it's a trade-off between getting more data but if your site is changing often, you may need to actually have restrict the amount of data that you collect. With an e-commerce site, it may not matter so much. So if your products are not changing on a daily basis, then you may be able to use a bigger window. Oh, I think a bigger limitation, I skipped over this, is prefetching only works after the first link. So you actually need to load one page of the site, and it's after this that links on the site are prefetched. So if you've got a ridiculously slow first load, then you still have a bad user experience. So the other techniques, so using a CDN, optimizing images, all those are still important because your first page load is very important. I think we mentioned unpredictable people, dynamic sites. So could prefetching work in dynamic sites? Because the problem with dynamic sites is I go to a page, it prefetches something. When I actually click on the link, the data that I have is, for example, a couple of minutes old. What React does is they've developed a process called hydration, and we can use it. I haven't implemented this in faster web, but you can use a process called hydration where you load the prefetch, but at the same time you request from the server the most up-to-date content, and then you hydrate the current page. So the technique will work fine in dynamic sites as well. And thank you to the comment about server push, about being deprecated. It seemed to have huge potential earlier on, but I think there've been some issues in the way it's been implemented. It's worked in production.
Yeah, I see Ronak is sharing another piece of information that for the product search pages, for example, prefetching first few results of the search was very successful without actually trying to predict where people will go. I personally feel that its search pages are different in that perspective, because the whole recommendation algorithm of the search page itself is already that prediction. So it's a little, like, obviously a little different here, but David, please share what.
And you're exactly right. So, for example, Google, when they serve their results, they prefetch the top few links. So that makes perfect sense. So if in your site you are generating a list, you're almost certain that people will click the top few links. So in a way, you have intelligently predicted, based on what someone has asked for, that they will download certain links. Now I thought we could have some fun. I've written a very simple Chrome plugin where we can inject the prefetching code into any site. And so the faster web code works by gathering analytics and then predicting where people will click. So we don't have any historical data. So as we use the site, we will in real time generate those predictions. What will be interesting for me is that I'm using this technique rather than using a service worker or the link algorithm, using this diff, and we're going to break the onload event. So we're definitely going to break some sites, but I've already tried this on one site. So let's give this a go. If there's a website that you'd like to test prefetching on, please put that in in the chat, and maybe Sergey can quickly check the link and let me know a site that you'd like to try it on. Yeah, I love the power of JavaScript because we can do experiments like this in real time. So this is my demo site that we've already seen. It was fun on the demo site because I can actually show the percentages directly on the screen. This is our production site. So if I load this is in Spanish. You can see the predictions that it's making. And so, yeah, if I click on one of those, the prefetch links, this one opened in 23 milliseconds, incredibly fast. Let me now enable this Chrome plugin.
Yeah,
and all of that is in
Alex sharing premierpops.com website. So if you can try that.
Cool. Let me open that. Great. So first of all, I'll test this on a site that I know will work beautifully. I chose the MDN documentation site. This is like a perfect example of a site because it has very limited JavaScript. So I don't need to worry about onload events, etc. So let me reload the site. And I have used this before. So it's telling me that 100% of the people have clicked on the next link. And I click on that and bang, it opens instantly. I can now see that in the way I've used it before, 40% of the time I've used this link. I'll go next again and overview. So just by injecting the JavaScript into this site with zero configuration, it works beautifully. It's a simple site, but it won't be so simple if we pick a more complex site. So let me open the Premier Pup site. Great. So we see there are no prefetching has happened because it doesn't know where I will go. I'll click on available pups and I'll go back to the home page. And so you can see that it tells me 100% of visitors have clicked this link. So if I click on that link, bang, it opens instantly. But I've broken things because I'm guessing these particular images are lazy loaded. So I would, in the configuration of faster web, define that I want the lazy loading JavaScript to run. If I refresh the page now, then I think that those images will load. And I'll click to some other links. And back to the home page. And back to the home page. And we can now see that 67% of visitors, which is just me, have clicked on this link, and 33% have clicked on that. So in real time, the analytics are being calculated, and the acceleration, the prefetching lets pages load pretty much very close to instantly. Cool. So thank you for that. I don't know if we need to demonstrate this on any other sites. The open source library developed by Google is called guest.js. That is more flexible in that it, especially if you're using React, that is the way to go. If you've got a large code base and a static site and limited JavaScript, the faster web implementation is very easy to install. There's a few sites using it. Eventually, I might charge for the service, but at the moment, I'm interested in collecting data and just getting this to work better. I've also got a full-time job and 3 kids, so I've avoided developing any features that people don't need immediately. So I've developed features for my organization and a few features just for fun. But if there's someone who has something that they need, then I'm happy to put some extra work into it. So, I've just got, I think, one slide left.
Well, you do that. I wanted to say that Bobby says that the next framework, Next.js framework, is also doing that already internally and loads the, because it's a React-based framework, it loads the data predictably as well. So that's another good example of that.
Yes.
This kind of approach.
Cool. And so, yeah, Next is, as from my understanding, Gatsby and Next have actually worked with the Google team that built guest.js. And so this prefetching is built into what how those work. So very interesting about fetching not just pages, but the data as well. And so some next steps. Please join the New York Web Performance Meetup. There's so much to learn, and I've learned so much being part of the meetup group. There's also a really well-explained podcast by Nick Molnar about web performance in general, and I've included some other links here. And if you've got a site where you'd like to try prefetching, please send me an email, and I'd love to chat. And so what we've done with prefetching is, while it's really difficult to get that truck to move any faster, we can't change the laws of physics. What we've done is move that data right next to our, right inside our browser, either in browser cache or in memory. So it's available instantly. So we're able to beat latency with intelligent prefetching and achieve a sub-second page load and give our users an amazing experience. So thank you, and I'd love to answer your questions.
I see that Alex is also pointing out that data from clarity.microsoft.com, their new analytics platform, might be a useful tool, useful information for this.
Cool. Thank you. Yeah, I only mentioned the Google's Guest.js, but it's good to know that Microsoft have got a tool as well.
Keep in mind that Clarity is a little heavy on their JavaScript.
Okay.
Just keep that in mind. That's my comment. I do have a question, actually. As you mentioned, this benefits only subsequent views, right? And service worker is also the technology that is specifically for subsequent views. It does seem like a great match, but you mentioned that there is this like optimization that it will lose, that it will not be on the page, right? So how much do you think using that within service worker will lose of this optimization?
Oh, I didn't understand. So was your question, you need to load the page first to get the service worker to work? And so there's a cost to getting that service worker to load. Is that your question?
No, what I meant is that in both cases with this technology, to be able to predict anything, right, and to be able to load something, it cannot work on a first page load, right? Same goes for service workers. So in that way, they are similar. But you mentioned that this technology, or at least this diff technology that you have, is superior to doing it using service worker. Can you evaluate like how much is the difference between the two? And
okay, I would actually say service workers are superior to this diffing technique. The reason for that is that the diffing technique is incredibly fast. So it's less than 100 milliseconds, but also comes with great limitations. And the great limitation is that it breaks how the page loads. So we don't have the on load and the other events. So for a small subset of sites where the developer knows which code runs, it's easy to add that to the configuration. But with service workers, we don't need to think about that. The service workers can do the prefetching, and I think that's the future. If we want to have a really simple way of adding prefetching, we could do it with the service worker. I think I need to do a bit more work with the production side and working with service workers, because there were some tricky things with service workers. If you make a mistake with service workers, you can end up with a site that's broken but hard to update.
Yep. Bobby is also talking about the data speeds. Do we know? I'm not sure if it's related directly to the talk, but he talks about, do we know the distribution of data speeds globally? Like he's saying that in US, 3G phones were not sold since 2018, for example. And Verizon is deprecating their 3G network here. He probably refers to your Peru experience.
Yeah. So I think in Peru, we actually have fantastic bandwidth in the cities. So we actually have better mobile internet in Peru than here in Sydney in Australia. And the reason for that is Peru have got their technology quite recently. In Australia, in Sydney, we have a lot of old technology that will take years to replace. And the other problem in Sydney is that you've got all these high-rise buildings. So I can be in the middle of Sydney. There are lots of spots where I only get 3G because the 4G is not working and it defaults to the 3G. So I think in large cities like New York, San Francisco, where you've got tall buildings, your internet coverage often isn't as ideal as it could be. So while all the new networks are 4G, there are lots of spots where people don't have great coverage. And if you just want to cater for desktop, then you can pretty much guarantee they'll have a good connection. But if you're covering mobile, and with our sites, we had 2/3 of people on mobile compared to desktop. When you're covering mobile, all bets are off. You just don't know what you're going to get. And real user metrics are the only way you can be sure.
Yeah, and don't forget subways in New York as well. So, as a recent user, I can tell you the network connectivity is spotty, especially between stops. Saif is asking, why can't we use link rel prefetch as inline code in our HTML page where we need it?
Yeah, the prefetch, we should use that. So I use that too. So in sites where I'm not doing prefetching, for example, I've used the pre-render on a page where there's just one button, and I know that that is the only link on that page, so I can use a pre-render. So if I am able to predict where people are going to click, then it's great to use that. But the challenge is that a page has hundreds of links, and up front you may not know how users will use a page. So prefetching just does that automatically, and prefetching solutions generally use the rel prefetch tag. So for example, guest.js, that's exactly what it does. It adds those, if it's a non-React, it uses the rel prefetch tag to do the prefetching. So yes, you're right. We should use the rel prefetch, and the prefetching solutions do use that.
Mm-hmm. Mm-hmm. Christian is saying that service workers are a great technology that will improve your website, and marketing team will love it for sure. And specifically regarding the metrics and the like search results, right? Rich is asking, question number one, what would be a good number of pages to prefetch? Off the top of my head, I'm guessing this is a function of bandwidth latency, average dwell time on the page.
So I have just used something very simple so far of just the top 5 pages. But if for example, there was a use case, I could say we want an 80% cache hit rate. At the moment, I'm getting under a 70% cache hit rate. I could say if you have, for example, a fast connection, 4G or above, get enough links to guarantee an 80% hit rate. So in your prefetching algorithm, you can decide how many links to prefetch. I just arbitrarily chose 5. I sometimes on some sites 6. And it also depends on the size of the pages. I think you mentioned that. So based on the bandwidth, if someone has got great bandwidth and a good connection, then you can prefetch more. If they've got a poor connection, then you prefetch less. Any workarounds for Safari? Yeah, that's a good question. I still can't believe that rel prefetch has been around for so many years. Internet Explorer doesn't support it, which I'm not surprised. But Safari, I don't know what the workaround is. But of course, you can write your own JavaScript, which is what I've done with the diff algorithm, and there are other ways to do that as well. But service workers will work on Safari, and I think service workers are a fantastic solution.
Yeah, I wanted to say that Safari, like the technology that is not supported in Safari is rel prefetch and service worker and whatever, right? But JavaScript, it works well, right? So you don't have to like this can be like literally part of your application. And that's what Next.js does, right? And you know, actually, I don't know what Next.js does on Safari, like in terms of like prefetching, you know.
Yes,
and yes, Safari supports service workers. That's a good point, Christian. Yeah, so they have different levels of support and everything like that. But yeah, they're real rel prefetch. They don't. Yeah.
It's okay.
Yeah. I wanted to ask a question. So why doesn't everybody do that? Like, what stops everybody to just do it? Because it seems like sub 100 millisecond response. And even if sub-second response, right, like with service worker, would be mind-blowing. Like, basically, I will quit. Web performance. I will not need to do anything else. Like, why is that not being implemented? Like,
from my
why?
perspective, I'd love to hear what other people say. From my perspective, I think there is just so much for us to do in the performance space. For some sites, it doesn't matter, the prefetching, because if your website generally has people just visiting one page, so people do a Google search, they visit one page and then they're gone, then adding prefetching doesn't add any value for you. It's also adding extra complexity that people, I think, don't want to look at. So, for example, you want to architect your application in a way as simple as possible. And I think we don't yet have the tools to make it really simple to add prefetching. And so one of my goals with Faster Web is to make it ridiculously easy to implement. So possibly in the future, just installing an NPM package. But there are some complexities in making it very simple to implement. Yeah, love to hear from other people's perspective. Why don't you use prefetching?
Brenda is saying that somebody developed a similar plugin for WordPress as well. It seems
cool.
Yeah, and yeah, my experience is actually the same. It's mostly application complexity that stops people from doing better caching, better prefetching. Like, it's getting out of that mindset of everything is real time and dynamic, that it must be going all the way to the database, and like even if they solve some of these problems, overall this is like the biggest problem. Prefetching has also caused issues by creating more load on servers. That's also a good point. Yeah.
And thanks, Rich. And I don't know if I mentioned already, but you are creating a bigger load on the server by prefetching more pages, of course.
Yeah.
And please, if you are interested in prefetching, I don't develop features just for fun, but if someone would like to experiment with Faster Web and prefetching, please let me know. At the moment, my organization and a couple of other sites use it, including the Cuban Sugar Association. So feel free to get in touch with me.